right? Spring. From this one, you see. Okay? See? It's cosine, right? But if you add them there, right? Then you have another term, right? What? In this case, let me put this one. Sine omega nt, this term there, right? This term in that one. And in front, we have sine omega n because of this one. Right? Okay? If no this one, because you know size is equal to C over C sub C, right? If you don't have this one, it means C equal to 0. Psi equals 0, so this one will be 0. So you have this one. Right? E to the 0 is equal to 1. Right? So the system itself is stable. So how come is it possible to have this one? Is it possible to have this oscillation? Okay, is it possible to have this one? Inhomogeneous, no. Right? Right? So, to have this one, you have to have F. Right? The system itself is stable, right? But F, this one, is actually equal to the frequency, equal to natural frequency. It will be something like this one. See? Okay. So any building or with no external input, right? It will be static, right? It stand there without any collapse, right? Okay. See, so if you add input and this input is equal to natural frequency of the building, it's collapse, right? You want to increase natural frequency, is have to make building more rigid. The natural frequency will be go up. Okay. Okay. That's the thing that I would like to mention for this one. Okay, for second order system. So if look at this one, if you have second order system, okay. If you have second order system, sorry. Okay. Second order system. Okay, you have this one. Okay, second order system. Okay, you have this one. You can write in this form. This form. For linear time invariant. You can write in this form. Let's say ft. You see? You can write your system, convert your system to this form. Okay? And if you can find size and omega n, you will see about, you will detect a lot of things about this natural frequency, this system. Right, this one. See? Because you can tell many things from this, just only two more parameters. The original one will be this one, right? Right, this one. It's quite difficult to tell something about the response based on MCK only, right? But if you convert this MCK into sine omega n, you can predict right away by watching these two parameters, right? Okay. See? Okay. That's the general of the linear time invariant system for second order system. Right? This is we call, sometimes I call it standard form. Standard form. Okay, right? It's standard form. Okay? So look at this one. See, you have this one. Okay, if I can tell this one, you have this one, right? This one. If I've written in this one, you have 2 sine omega n equal to 4, omega n square equal to 10, right? Right? So omega n is equal to square root 10, right? Sine will be equal to 4, right? To omega n, right? Something, right? Alright, so whatever. So this is less than 1, right? Less than 1. Oscillation, you see? See? Oscillation, see? You can tell that way. Some oscillation. Okay. Okay. Look at this one as well. This one. See, you have actually this unstable. This one, you have this one. See, look at this one. You have let's say this one is unstable, right? You have this one. See, your lambda is so this one is unstable. You see, this is gone up, right? This one. Okay, you can tell that away. Okay. This one as well. See, minus this one, unstable. See, I can see it that away. Minus this one. So this one you see, unstable, right? Actually, it's go up as well. Okay. Okay. The other form, Cauchy, this one, similar, right? As I mentioned last week, right? Last Monday, right? We have to solve this one, right? But I substitute this one to equation. Previously, we used this one, right? To substitute on y solution instead, right? Y equal to e lambda x, right? From previous equation. For Cauchy, you use this one, a, right? So, and you can find characteristic equation, right? You can find characteristic equation, and from characteristic equation you can find eigenvalue, right? Okay. So the way is one, but if you have this form, let's say, see, you have this one. If you have this one, go to solve this one for this one. You cannot use this method. No. Okay. If you have this form, it's not compromised with this one. No. So you cannot use this method to solve. No way. Okay, this one is a little bit difficult, right? I think this one is better to use a numerical method to solve actually. Okay? Okay. Okay. So we have three cases, same. Case number one, distinct root. Case number two, case number three is, right, repeated root, right? And you have in terms of x, right? Now, in this form, you have log x. If you have repeated root, log x instead. Okay? Okay. Okay, so this one, yeah, this one can be used Cauchy for general solution, right? This one. Okay. Okay, that for the last one. I mean last week. I mean last Monday. Okay, we do have another one, another slide concerned about second order differential equation only. Okay, so actually it's already in that, in the previous one, right? If you have you see that one, right, from integration, right? You have, you look at this one, you see this one from integration slide, right? And you have second order here, right? I put more, I move this one to this slide anyway. Just only second order, right? But it's not the same anyway. Okay, You can solve, you see, okay? For this one, you have this one, right? Y double dot or y double prime plus fy. Look at this one. Okay? This one. You have this one and this one and this one, right? Actually, this is a linear system. X independent, right? And because of the coefficient is a function of x, right? So this we call linear x invariant, x variant, x invariant. This one, this one we call x variant, varying. Okay, x varying this one, but this one x invariant this one. Okay, this one is not that difficult to solve, right? Just told you, right? This one is more difficult. Okay, this one is more difficult, right? This one you can use similar, right? E to the lambda x to solve, right? This one. Right? Okay. Homogeneous solution is equal to 0, right? And you have another one, Cauchy, this one, right? This one. Okay. So I just move. I mean, just more summarize from the previous slide to this one. Okay? Okay. That's everything the same, right? This one, everything the same, right? Okay. Okay, right? Everything the same, right? But more, maybe give you some more detail for this one. Okay? So everything the same, right? This one. I add something here, right? Omega n is, sorry, this one. This one, I add more detail, but there's something wrong with this one. K over M, not M over K. K over M. Okay? Okay. This K over M. This one will be K over M. K over M. Not M over K. Okay? Okay. Sorry. KOM. Right. Okay. This one is switch. Right? This one had to be N. Okay. So had to be this one. Okay, it's not this one. Okay, radian per second. Okay, sorry for this one. Okay, so this one as well, you see natural, we can see this one will be K over M. So if you don't have dam here, right? This one. Okay, the previous one, if I have this one, okay, this one, okay, we're gonna have this one, right? Instead of this one, we're gonna have this one, M y dot plus c y dot plus k y equal to 0. You have this term, add to this term, right? This one, okay? And we also put some, add this one, y minus psi square. If you have this, right? From previous, right? So right, you have this one. This one we call omega d. We call omega d. This one. Omega n stand for natural frequency. Natural frequency. Omega d stand for damp natural frequency. You can see. Okay? So if you have C here, you have some damp natural frequency here. Okay? Could be natural frequency and damp natural frequency equal to this one. So if we don't have C here, this one will be 0. Right? So omega n and omega d will be equal. Okay? Okay. Okay, so just give you more detail this one. And the solution, you see you have this one, right? You have this one. You have this one. You can convert this one into a cos omega nt plus phase. This one can be converted this one. Okay? Or sine, a sine omega nt plus phase, another phase. Anyway. Okay? How to convert this one? You have this form. Okay? This is a way to convert. Use sine cosine law. Okay? So you can convert your phi here, right? Yeah. Magnitude phi, see? Okay? So just look at this. So sometimes I want you to write your solution in terms of magnitude and phase. You have to write this form. Okay? Okay, so just use cosine law, sine cosine, right? This one. Okay. You have this one, oscillation. See, if you have this one. See, you want to model this one. Similar to this one. See, in this case, you use modify Newton-Euler equation, right? Summation top equal to J theta lambda, right? This one. Okay? So in this case, mg, you take moment here, right? mg L sine theta force, right? Equal to J theta, right? This one. Right? See, so you have second order system, right? You have second order system, right? So you have theta double dot equal to, in this case, mg over j sine theta, right? This one, right? Or in this case, you can combine this one, mglj sine theta equal to 0, right? This one, right? This one can be written this one. Okay. So it's second order. Look at this one. See, but nonlinear. Yes, nonlinear. Right? This case. Right. So if you look at this one, you have this one. It's nonlinear in this case. You can approximate. Right? This one. Let's see. Okay. So let's see. You can write in this form. Okay. Look at this one. Let me show you this is for this one. Okay. If I lighting this one, it will be like this one. Okay, it means it's theta will be this one. If you move this one, okay, theta will be this one. Right? You look at this one. This picture, theta will be this one. Okay. But if I written this one instead, okay, I said this theta is positive. Right? Let's say if this theta is positive, right? I move this one, right? It will be this one, right? Right? So you have this one mg, this theta in this case, right? But this one theta in this case, right? This one theta, the opposite direction, right? Okay. Look at this one. If you have this, my equilibrium point, right? I say, okay, my theta will be positive here. Right, this one, right? The other one is this one, if this theta will be positive. This one. So you have different theta in this case. That is opposite that one. Direction. Okay? Okay, so let's see if I have this one. Okay, I move this one. Let's say I have my original here. I move this one to this one, right? Okay, move this one to this one. Okay, so in this case we have, let's see, okay, if theta in this case, right? So you have this one, mg L sine theta, right? This is L sine theta. L sine theta. mg L sine theta, right? This one, right? But actually, this direction, right? This top rotate this direction, right? Okay, but theta will be this one, right? So in this case, you can put minus equal to j theta lambda, right? So you have this one instead, right? Right? Okay. Theta plus here. You put theta plus here. Okay. So you have that one. Okay. So in this case, you have this one, j theta lambda plus mg L sine theta equal to 0, right? This one, right? But if this one mgl is minus, look at this one minus, this one minus, you see? If you substitute, you see, in this case, it rotates different direction, right? Okay, so in this case, you will have this one. You have this one, right? Let's say if I modify this one, okay, theta dot equal to mgl, right? J sine theta, right, equal to 0 in this case. See? This is a parameter, right? System parameter. This is a nonlinear term, right? If theta small, sine theta will be equal to what? If theta small, sine theta will be what? Huh? Why? Can you prove that?
You can do the sandwich theorem.
Can you prove it? Okay, the problem like this one. Okay, theta small, sine theta will be equal to what? Theta, right? And cos theta will be equal to 1, right? Why not this one to be 0?
It's not 0, it's almost 0.
Can you prove that? Why it's not 0?
You can do it using the graph, or you can do this using the graph, or you can put in the values instead. Also, Professor, you can use the limit, like limit sine theta divided by theta is equal to 1.
Now another problem, another topic. Linearization. If we have function y the f theta, let's say, okay? If y then f theta, you want to linearize it. Linearization, right? With respect to theta equal to 0. You see? Let's see if you have this one. You see, you have this one, right? Sine theta. I want to linearize this one. Okay? With respect to theta equal to 0. Okay? Okay. Right? How can we write this one? We can do Taylor series. Have you heard about this one? Taylor series. Every function can be written in the what? Taylor series. In terms of this one. Plus okay, Taylor series. You have this one. เคยเห็นไหมเคยเห็นไหมเคยเห็นไหมนี่ calculus ดูสิต้องมีอยู่แล้ว right? This for only a single variable, right? This one you can have this one. If you want to linearize this one, see this every function can be written this form. If number of terms is infinity, it will be equal to that function. Okay? See? To infinity, let's say infinity order. Right? If you can make it infinity, it will be equal. So if you want to linearize this one, you just assume this one will be 0. Above first order will be 0. Right? This one. So in that case, if you have this one sine theta, you want to linearize with respect theta 0 equals to 0. Right? So you have this one, right? F theta is sine theta. Right? Theta equal to 0, right? Right, this one. Plus sine theta, right? No, cos, sorry. It should be cos. Right? Cos theta theta equals to 0. Right? Theta minus 0, right? This one. Right? You see? This one. Right? So, this one will be 0. This one will be 1. This one will be theta minus 0. Right? So, this one will be equal to 0. So, linearize of sine theta when theta is small, when theta approach 0, is equal to 0. See? And equal to theta, is it? Theta, right? This one, see? Disapprove. Good, disapprove. You can do cos if theta is equal to 0. Okay? You can do same. If y equal to cos, I want to linearize this one. First of all, cos theta equal to 0, right? Plus the cos y is minus sine, right? Minus sine theta, right? Okay? And theta equal to 0. Theta minus 0, right? This one. So this one equal to 1 minus 0, right? So cos theta approach 0. This one. See? This one. Okay? So that's a proof anyway. Okay? Okay. So let's go back to this one. Okay? So if you want to modify this one, I mean, if theta is small, so in this case, you see sine theta will be equal to theta, right? Okay, so you have this one. Okay, so you have this one. A different theta direction, right? This one for this direction. Okay. Okay, this one. Okay. So actually it will be something like G over L theta. If J here, J of this one is what? ML square, right? J in this case ML square, right? So you substitute this one, so you have this one. Natural frequency of this one will be G over L. G over L. Okay? Natural frequency of this one. Okay. there's one of the midterm exam. This one. If I have a cuckoo clock, have cuckoo clock. Okay, have cuckoo clock. And it's swing, right? This one. อันนี้ก็ข้อสอบนะ You have swing there, right? Right. Right. ในการ Normally, if you have cuckoo clock, and that cuckoo is a very old clock anyway. They have some screw here. You can adjust length. This one can adjust length. Okay, length. If the clock is moving too slow, how do you adjust it? Increase L or reduce L? Okay. If the clock is moving too slow, how to adjust length?
Use L.
Right? Okay, let's give you as a exercise for you to do it. It used to be midterm exam. Okay, next you have this one. Okay, you have this, right? Yeah, similar Cauchy and Euler Cauchy, right? This one. For second order, you have this one. I already explained, right? This one. Okay, this one. Okay. Have some. This one have more details to solve. I'll give you some solution to solve this one. Okay. If you have this one, see. The example, let's see. In this case, you see, this is not a homogeneous solution. Okay, so first of all, you solve this one first. Okay, equal to 0 first, right? So you solve for this one, you have this, right? So y homogeneous solution will be what? C1e to the minus 3x dot to dt, right? Plus C2 e to the minus 2t, right? This one. Okay. So look at this one. Okay. So you have this external input, right? This one. This e to the t is not the same as one of these, right? It's not the same as one of these. So you can assume this one, yp equal to a e to the t. And you substitute, you have a equal to 5. So your particular solution will be minus 5e, right? Y homogeneous, y particular will be equal to minus 5e to the t, right? This one. This homogeneous solution, the particular solution, right? Okay. If this one is equal to one of these one, in that case, you need to yp had to be ut e to the minus. Actually, you have two of these. I will show you more. Okay, I will show you more. It's something like this one. Yp should be c1t e minus 3 plus c2t e minus 2t, right? This one. Okay, we will use this one. Okay, if you change this one to this one, I will show you more detail how to solve this one. Okay, but this one, because this one is not the same as the homogeneous solution, right? This one. It's not the same as this one, you see. So in this case, you see, you can assume your particular solution to this form. Okay? Okay. Or you can solve this one. I show you. This is, you can use MATLAB to solve. Okay? This one. Okay, you want to solve whatever change some of the parameter. Okay. Okay. Okay, that's just more detail anyway. Okay, I would like you to, yeah, this one is the one that I just mentioned to you, right? Previously, I think you should understand this one, right? Next one. Look at this one now. You have second order, right? For example, if higher order, okay, for any arbitrary order, right? Arbitrary order, this one. Right? Arbitrary order. Let's see if you have this one. Let's see. We cover for higher arbitrary order, same. We will cover just only linear time invariant. Time invariant. Right? And some special Euler-Cauchy. Euler-Cauchy. Same. Right? For example, let's say if I want to solve this one, okay, let's look at this one. Let's see if I want to solve this one.
But that's not.
Okay, look at this one. Let's say if I want to solve this one. Okay. Okay. We have this one, third order. How to find this one? I want to find y. This is higher than third order, right? Do the same, right? Because this one linear time invariant. Right, this one. We substitute, we assume our solution if we go to e to the lambda t, right? This one. And substitute this one to this one, right? Okay, so you have what? Y dot equal to lambda e to lambda t, right? Y double dot equal to lambda square e lambda t, right? So this one lambda 3 e to the what? Lambda t plus 3 lambda square e lambda t plus 2 lambda, right? E lambda t, right? Plus e lambda 3 equal to 0, right? So in this case, you have this one, lambda, right? E to lambda t equal to 0, right? So characteristic equation will be this one. Equation will be this one, lambda 3 plus 3 lambda 2 plus 2 lambda plus 1 equals 0. So now, what is the lambda? Can you solve this one? Okay. What's the lambda 1, lambda 2, lambda 3?
You have to use x axis.
Lambda 2,
Just write x, just like
lambda 3. Okay. Can you find this one? You don't have calculator, right? I can do this one by this.
Right axis and then axis ax axis.
Okay. So you look at this one.
Write down
See, you have this one. Lambda 3, right? So you can find this one.
and then
Yes, you can use this one. Root of 1, 3, 2, 1, right? Right? This one. Okay, so you have this one. You see? 1, 3, 2, 1, right? So you have root of this one. You see, you look at this one, okay? So your characteristic equation will be this one, right? Lambda 3 plus 3 lambda 2 plus 2 lambda plus 1 equal to 0, right? So you have these 3 lambda, right? So it's a combination of this one. See? So lambda 1 equal to minus 2.3247, right? Lambda 2 equal to 0.3376 plus 0.56231 J or I, right? Minus 0.3376 minus 0.5623 J, right? So the solution will be, right, y homogeneous in this case will be C1 e to the minus 2.3247 t plus C2, this one e to the minus 0.3376 t, right? For this one, cos, right? 0.5623, right? T, right? This one plus C3 e to the minus 0.33763 psi 0.623, right? This one. See, it's a combination anyway. You see? So if you have third order system, you're going to have 3 roots. Those roots can be what? Repeated root, complex conjugate, or distinct root, right? So you have this one. Similar. And the solution will be this one, C1, C2, C3. In this case, need to be found from initial condition. Okay? Okay. Same. Okay?
Professor, could you explain what the roots does again? Like what the function roots defines the roots for the third order equation?
This function root, this one, if you have polynomial, this one, right? 1, 3, 2, 1. 1, 3, 2, 1. Find root of this polynomial. This one. Okay. Right? Just about the same anyway. If you have a higher order, right? You can find homogeneous solution. Right? Similar. You see this one. For example, this one, right? You have this one. Your characteristic equation will be lambda 4 multiply plus lambda 3 plus 26 characteristic lambda 2 plus 40, right? Plus 25 equal to 0. This is a characteristic equation. If you do exam, if you don't write this is a characteristic equation, you will reduce mark. You have to write. You have to learn, practice, and make it to be your habit. This one. So you solve this one. Actually, there are 4 roots. 4 roots of this one. Right? So in this case, okay. This one can be similar, right? This one. Okay. You can do this one. Root of this one will be what? 1, 8, 26, 40, 25. Okay, do this one, right? So all these are compared together, right? All these are compared together, right? This one. So in this case, my solution will be like this, right? This one, you see, you have this one, right? Now they are repeating root minus 2 plus minus what? J or I. Similar to this one, minus 2 plus minus J, right? See? Okay. So how can you read this, write this one, right? You see, you have this one and this one, right? Say, so how can you find this one? How can you write this one? How do you do this? Because of 2 repeated root, this one, right? So how can you write this one? I let you do it. Okay, hold on. Sorry, look at this one first. Okay, look at this one. I change my files. Okay. Okay, so this one you have 2 complex conjugate, 2 set, right? Similar to this one, right? So how can you write down the solution, right? Okay, try it. There are two examples in this case, right? Okay, see you have 2 of them. This one, you have 2 of them. And you can write this one. If one of them can be easy, right? This one is minus 2 t, let's 2x, let's say, cos x c1 cos x, yeah, this one. This one, c1 cos x plus c2 e to the minus 2x sine x, right, for this one. You see, you have this one, right? Okay. Okay, so if you have this one, how can you write this one? Okay, it's the same, you see, this one here is the same. So the second term, what? Okay. I leave it for you to do by yourself. Okay, you see, you have the homogeneous solution, right? You do the same. Substitute this one and you have characteristic equation this one and can solve for this one, right? So if you have triple root, you have x, right? X lambda, right? If you have third order system, you have triple root, you have this one solution, right? If your roots are similar, right? I mean equal, right? In this case, if lambda 1 equal to lambda 2 equal to lambda 3, you can have this one, right? Y equal to C1 e to the lambda x plus x C2 x e to the lambda x plus C3 x squared e to the lambda x, right? This one. If you have 3 repeated root, you have this one. Okay, if you have 3 distinct root, you have this one. Okay, okay. So in this case, you have this one, right? Okay. This one you have 3 distinct root. I mean 3 triple root equal. This one. So this one, you see this solution, right? You have this one. You have this one. Similar. Okay. So you have this one. Okay. See this one. You have the example. This one. To the fourth, right? So you have this characteristic equation, and your root will be like this one, right? So you have two roots like this one, different, distinct. So this one will be for this, and this one will be for this, right? This one, the one that I would like you to do it, right? This one, you have to similar to this one. You see, 2 of this and 2 of this, right? 2 of this and 2 of this, right? So you can do this one. And the other 2, this will be this one, put x here. This one. Okay? Okay? The other one you can find this. If Cauchy, this one x to the 3 y third, this one do the same minus 3x squared, give this one 6x prime, right? This one, if you want to solve this one Cauchy, this one x y equal to x to the m, right? And substitute to this one and solve everything the same, do the same, right? Okay, I don't want to repeat this one. Okay, to the m, and you have characteristic equation this one. So in this case, distinct root. So your solution will be this one, right? Okay, now let's see. All the solution, see, all this one have to be independent, right? This thing is independent, right? It's not distinct, it's repeating, it's not independent, right? Okay. This one is how to check independent. That's okay. Okay. See, you have this one. You want to solve this one. You see, you have how to check independent. Let me. If you, I don't think you do. You can read this by yourself. How to check independent, right? Do not. How to check independent this one, but you can do. I will show you by example. Maybe easier to understand. Okay. Look at this one. If you have this one and this one, y1 and y2, we want to check this one independent or not. Okay, one way to solve this one is, you see, cos x and sine x, right? The other one, tip of this one, sine, hyperbola sine, tip this one, cos. Okay, and next, see, this is a d by dx, right, for this one. Okay, and check determinant, right? Okay. See, if it's not zero, it means that you're independent. These two are independent. Okay, so this one is independent, so you can write a solution like this one. Okay, so check independent. It just put in the matrix and find determinants. Okay, if it's not, if equals to zero, it means that it's independent. If not zero, it means that it's not independent. Okay. Okay. Similar, if you have repeated root, right? You have this one log x instead of t, right? Or log t, right? This one. Okay. Okay. Linear homogeneous. Okay. This one now. That's okay. Okay. So look at, if you have already did, you see you have this one, right? You can read by this anyway. This one, you see you have this. You want to solve this one homogeneous. You have this one. You see, this is characteristic equation. You have eigenvalue this one, right? This one. To repeat, right? So you have this one. Can be written this one, right? See? And this one, not repeat anyway. This one can be written this one. Okay? This is solution. Okay? The other one, okay, now non-homogeneous. Now non-homogeneous. I will stop here for this one. Okay, next time I will show you how to do particular solution. Say if you have RT, if you have RT, right? How you assume YT? How to assume this one? Based on this Rx, how to assume YP, right? Next time. There are two methods to assume one particular solution. Okay? Okay, that's for the lecture, right? This one. Okay. I have some workshop for you to do. Okay.
วันนั้นเรากลับเวลาผิดตอนที่เราทำวิทยานิกเราคิดว่ามันแค่ว่าดวงสมตัวเราทำเป็นแต่พอมันมีแอร์ด้วยทำเป็นแล้วก็มันหมดเวลาว่าจะว่าแค่คือแบบหาแบบเป็น average หาเวลาแบบใช่เราทำไม่เป็นอะไรทำให้มันแบบชัวร์นะคะที่มันก็มีวิดีโอโชว์ไม่เป็นไรน้องคงพันออกมาเครียดจังเลย
Okay. I have some workshop for you to do. Look at this one. For, I mean, the slides under integration, this one. Okay, the integration, this one. We have this one. I have this problem, this one. Okay. Let's see. I want to find the temperature model. This one, this room. Right. We want to find pt. Right. Right. tt. Let's see. T in. T. I want to find this one. Solution of this one. Now look at this one. You see, you have this one. Look at this. Now outside temperature is not constant. Outside temperature is just constant. Okay. Look at this one. Not constant. Okay. And let you do this one for this room. You do this one, but I want to find temperature distributes in this room. Okay? Okay. I think this is a very good problem for day to day when you are, when you grow up, when you work outside, whatever. You sometimes see some of these problems. Okay? So I give you some of this, okay, more detail. You see, you remember this one. If I using conservation of energy, right, in this one, right, look at this one. Aduna. See, dt in by dt equal to q in minus q out, right? Q in, the visual input, right? Q out is for distribution, right? Okay. So you have to C. What does it mean by C? I gave you this number. C is stand for thermal capacitance. It's J over degree Kelvin,อุณหภูมิ Kelvin นะ Okay. Air capacity inside this one is equal to volume. Right? Look at this one. It's equal to volume. Volume is one. And density of air. Density of air. And what? This one we call heat, specific heat. Specific heat. Right? This one specific heat. Right? So C actually is parameter that tell you how they can absorb energy, how they can absorb energy in this room. There you have volume, right? Volume is right, length, width, height, right? This one, right? Volume, right? Density of air density, this one. You can actually see the table, this one, okay? And specific heat of air, this one. All these units are in SI unit. So C will be this one. C will be this one. Look at this one, it's like a constant, right? Right? So it means that inside, like a mass, right? Like you are speaking a mass, you have mass parameter and constant, right? This one also, this is a constant anyway, because of this rule, right? Right? So you have this one, it's heat capacity, how it can absorb energy. Okay, this rule. Okay, next, wall insulator. Okay, insulator of the wall is actually it's like a material thickness divided by thermal conductivity. การนำความร้อน thermal conductivity of the material. Okay, this one. You see? So actually, I give you some value. This one. R for cement, concrete. This one, concrete. Its I is about 0.052 for 75 millimeter. 75 millimeter. Okay? Or if you have wood, right? This one per inch. Or you have fiberglass, this one. If you have EP foam, this one. So if your wall consists of many type of material, R will be equal. R will be sum of those. R will be sum of those. Okay? ให้คุณฟังนะ แล้วคุณจะไม่เสียใจจำผมแล้วคุณจะไม่เสียใจผมอยากจะเห็นวิเทอร์ในตอนนี้ว่าคุณจะเป็นยังไงฟังไว้นะไม่ต้องถ่ายผมให้ไปแล้ว I give you everything this. Okay. So if you have more material, it's just a combination this one. But this one you have to be careful this one. Okay, you can find out this one. Okay. So thermal capacitance is like how much this room can absorb thermal. Okay, so if our outside temperature now is not constant, it's a function of time. Let's say if I have this one, temperature this one, 6 a.m. another 6 a.m. right? Then 6 a.m. you have a 35, right? Let's say. And up, it will be 45, something like this one. Right? See, outside room, right? This about let's say 2 o'clock in the morning. These all. So let's say we have this one. So the period of this one is 24 hours. It is this one. Okay? So, how can you find T out? I can find T out. Okay? Yeah.
Q in is a constant or?
It's constant, it depends on us. Okay? Q in is a constant anyway. It's the input. we just apply. In the future, Q in can be controlled, can be come from computer to control room temperature if you want. At the moment, you don't control it. You just want to see if you add some reasonable Q in, constant, maintain the temperature. Okay, with this parameter. Okay, so you have to start from this one. You have to start from this one. Okay? Start from this one. And try to find suitable Q in constant as an input. And so that I can plot T in from whole day, I mean from 24 hours, let's say. Okay? How you can solve this one? The previous one, T out is constant, right? Now it's changed. And now we have more value this one, more value this one. So you have feeling about the quantity number. How much you will put Q this one input. Reasonable one. Not one now. Right? Some step that may be bigger or whatever. Okay? And you will find out. So you have to vary Q in and see the response. Right? Very clear. See the response. Okay? So if you want to maintain temperature, this one, so that it's not too much fluctuates, right? With constant this one, just constant. How can you do that? Which constant amount that will be suitable for this one? Okay. So this is a workshop. You can do it or not. If you don't want to do it, it's your free. You want to do it. If he doesn't want to do, it's your choice. No problem. Okay. I just give you this one. Okay. So you want to do it. If he doesn't want to do it, you say, I'm robot. I don't want to do temperature. Go ahead. You don't have to do it. It's your choice. Okay? But if it's in the exam, no choice, you have to do it. Okay? It may not be in the exam, no problem. Okay? No, T in we have to solve. T in we have to solve. Right? You see, we have to put T in this one. Right? We have to solve. We have to find the simulation of T. Okay? Q in is an input. We just add some reasonable number. So you see temperature in the room. That's right. Okay. If look at this one, if T in, let's say we want to solve T in, right? If T inside, let's say if T in is constant, it means that this one and that one equal. Q in equal, oh, equal, right? Right? See? Okay. So I want to try to make T in this one. First of all, you need to assume that outside temperature, right? You have outside temperature, this one. Okay? Outside temperature. Right? Let's say start from 35 up until in the afternoon, maybe 45, let's say, for 24 hours. Right? 24 hours. Right? Okay? And you want to maintain this one. And you see T in is maybe, you see T in start from, let's